Okay, in this video, I'm going through some examples of finding the domain of a function. So last time I solved this question, which was the function f of x is x plus 4 divided by x squared minus 9. And we said that the only thing we should consider is that the denominator shouldn't be 0 because that's the only basically case that is causing some trouble. So in that case, we found out for what input values the denominator will be 0, which were minus 3 and 3. Then that means that the domain of this function is basically all the real numbers except 3 and minus 3, which basically means that we can give any x value to this function without having any issues except 3 and minus 3. Now, I'm going to start with this example, which is f of t is the cube root of 2t minus 1. Now, this one is an interesting one because some of you may remember that when you have a square root, the only thing that you try to take into consideration is that you look for the values of the x or the independent variable that you have that make the square root negative, and you want to exclude them from whatever set is that you're working with. But it's very interesting because in this case we have a cube root, and there is an interesting fact which is about if the root you have and the root is an odd number, then it doesn't matter if the number under the root is negative, if that makes sense. Because let's just look at some examples so it's going to make more sense. Okay, so cube root of 8 is 2, right? Now, what is cube root of minus 8? It is minus 2, right? Because minus 2 times minus 2 times minus 2 is minus 8. So what I'm saying is that the cube root of negative numbers is defined. It's not like the square root, which simply means that basically the domain of this function is just all the real numbers. So from minus infinity to plus infinity. Any number that you want, you can choose and you can plug in here and you can get the corresponding value for f of t, which means that you don't have any issues. So yeah, now in a nutshell, if the root that you have is an odd number, you can have negative numbers under the root, whereas if it's an even number, then you can't. So if, for example, you have a square root, you have the fourth root, you have the sixth root, and so on, you can't have a negative number. Because in real numbers, when you're talking about real numbers, it is impossible to have a real number that being multiplied to itself even number of times and give you a negative number. That is impossible, whereas that is possible with odd numbers. Now, the next example, we have h of x, which is equal to 1 over the fourth root of x squared minus 5x. Okay, so now some of the things I mentioned in the previous example are going to be applied to this example. So now this one is an interesting one again, because this time there are two things that we should take care of. So first things first, this is the denominator, so we should make sure that the denominator is not 0. So we should exclude the values that make the denominator 0. And also, we have the fourth root, which means that since it's an even number, we can't have negative here. We can't have negative here. So it must be positive, a positive number. So with that said, we should find the set of the numbers that are not negative and also not 0 because it's denominator. So all we have to do is that we just need to solve this inequality because we want to find the x values that are greater than 0. Basically, they are all positive. And then the reason it's only greater than 0 is because obviously we don't want to get 0. So yeah, now we just have to solve this inequality. So we can just try to solve this as if it were an equation, and then we can find the different ranges for x. So first of all, it's a very simple quadratic equation. You can just factorize, and this gives you two values for x. X is 0 or x is 5. Now obviously we should use this in order to write down the set of the numbers that are going to satisfy this inequality. So we can, there are different ways of finding the sets that are the solution to the inequality, but I'm just going to sketch the graph just to show you, because this is like the way that maybe makes more sense, but there are much more quicker ways than just sketching the graph. So this is 5, and you're going to have something like this. And now, as you can see, we want the regions that are greater than 0. So that's what we want. And just to highlight that, here is greater than 0. And also here is greater than 0. So these are going to be the solutions to this inequality. So we have from minus infinity to 0, union 5 to positive infinity. Now you might be wondering why I excluded 0 and 5. And that is simply because when you look at this denominator where we have x squared minus 5x, we can't have 0 or 5. Let's just substitute 0 and see what happens. So if we substitute 0 into here, we will have 0 minus 0, which is 0, and we can't have that on the denominator. And that the same thing is just going to happen if you substitute 5, because you're going to have 25 minus 25, which is 0. So hence we should exclude 0 and 5. And yeah, so this is basically the domain of this function. So that's it for this video. Thank you for watching. Make sure to like and subscribe for the future videos. Good luck.